Hi, I'm Stanislao from BeyondShape. BeyondShape is an official spin-off company made from University of Naples, Federico II. And with BeyondShape, we are specializing in 3D body technologies for the medical field. And today, this conference, we have presented Inbody. Inbody is our 3D body scanner, which has been certified this year as a medical device. And with Inbody, you start doing a 3D body scan, but you have also more. You have the 3D body the 3D body morphology reconstruction, but also the reconstruction of the skeletal models. And this is possible with our pipeline, which involves the 3D body generation, the extraction of anatomical landmarks, the extraction of measurements, and at the end, the generation of patient-specific 3D skeletal models. Here we have prepared a live demo. We have our 3D body scanner, which is in Naples, and we are going to have a live remote demo for a process, for a scanning process. And with me, there is Damiano, which is a computer engineer at BeyondShape, and Emilia Bellina, which is a biomedical engineer. So now we are connected with our scanner in Naples, and here there is a patient inside, which is this is live streaming from the internal part of the scanner. We have indeed in the internal part of the scanner cameras that live streaming also what is happening inside. And when we put on capture images, we have the acquisition. So the acquisition of more than 100 cameras, and starting from these more than 100 cameras starts our pipeline approach that I showed before. And now we're going to transfer all the images to our backend, where all the software for reconstruction, for body reconstruction, and for medical analysis works. So now there is the process of transferring the pictures, and this process is going to last for mostly a minute, because after that we have the acquisition of the picture, we have to translate the pictures to our software, which is on the back end of our workstation, and this is the process. Within our 3D body scanner, we have the possibility also to acquire the body morphology in multiple postures, and according to the clinical protocols that we are working on. In this case, the protocol is scoliosis protocol, and we have in a pose for extraction of multiple clinical indicators for monitoring. After the transferring, we are going to build the model, and the model is generated using photogrammetry, and photogrammetry is the techniques for reconstruction of 3D body models starting from multiple pictures. And in our system, we have the possibility also to perform multiple acquisition before doing the elaboration, because there are some protocols that we have implemented over the past years and past months, which requires the acquisition of the people according to multiple postures. And moreover, beside the acquisition over multiple protocols, we have also about multiple posters. We have also the possibility to acquire multiple protocols. And over the past years and months, we have developed also different protocols, as protocols for scoliosis evaluation, protocol for monitoring pregnancy women, protocol for the acquisition of body morphology of the arms, for the reconstruction and the generation of biomedical equipment as orthosis, wearable technologies, and robotic exoskeleton, because our single machine allows both the derivation of body measurements and clinical indicators for monitoring in a non-invasive way the evolution of a pathology, but also the 3D body model that we generate can be used for the construction and production of custom biomedical equipment. And now we have the 3D reconstruction is ready, and we have our model here. We can just have a rotation of the patient, and this is acquired both in gray color or with texture for the skin analysis, and after we can start the analysis. So by starting on the analysis, we open the 3D body model in our web app, and we start the computation of multiple anatomical landmarks which are computed directly on the body morphology, and starting from the 3D, starting from in a few moments they will appear here, and starting from the body the body landmarks, we extract all the information that we need, as well as measurements and models, shape reconstruction of the spine. And with the landmarks, we have also the possibility to work in different with the additional of multiple landmarks, also with the landmarks that are not included in that kind of protocols. For instance, for the evolution of the spine, we have a few landmarks that are used, but for different pathologies, you don't know exactly at the beginning where to put which is the landmark of interest, and then the clinician can also add manually an anatomical landmark if needed. Here we can see all the anatomical landmarks which have been computed, as well as the indices. The indices are all the measurements that are as output of our software, and in particular the most important measurements are measurements at the spine and pelvis level, which are related to Cobb angles, kyphosis and lordosis angles, or pelvic tilt and pelvic obliquity. And here there are also the measures. For each protocol, indeed, we have the computation of measures, and these measures are used, for instance, for the derivation of orthopedic corsets or other biomedical equipment. At the end of the process, we can visualize the body model, the skeletal model, and this visualization is embedded within this system, and this visualization goes on the back-end development of the spine model, which is based on the real anthropometric measurements and the real landmarks that are acquired on the shape. And One single machine for developing multiple kind of applications and a lot of data. A lot of data which are used for monitoring, for the generation of biomedical equipment, and data which are stored in our database and then can be used for follow-ups because this is very important for the standardization of the clinical procedures. And finally, we'll see here we see the visualization of the spine model, which can be seen here directly within the body and directly performed specifically for each patient without the using of radiation. So this is this concludes the demo, and this concludes also the mission of BeyondShape, which is developing non-invasive technologies for the medical health and the diagnosis. Thank you.